Welcome to the e-learning platform, an initiative by Science Park, Savitribai, Phule, Pune University. Let's start part 2 for standard 8, where I am covering chapter 17 from SSC board and chapter 1st and chapter 3 from CBSE board, where we are looking at man-made materials. Now, if we start listing how many man-made materials that we come across, so we see tiles, bricks, concrete, metals around us, various types of glass, plastic, rubber, and so on. So in first part we saw all the details about plastic, right? Now let's see all the details and the chemistry behind glass. Okay. Now in glass we'll see one by one as its definition of glass, preparation of glass, composition, variety, and then uses of it. Okay. First, let's get to know what glass is made up of. It's always made up of pure sand, soda, and lime. When they are heated together at 1700 degrees Celsius, glass is formed. Now let's see definition of glass. Glass is an amorphous, hard, brittle, transparent or translucent supercooled liquid of definite viscosity, having no definite melting point, obtained by fusing a mixture of number of metallic silicates or borates of sodium, potassium, calcium and lead. Now this whatever I read was a scientific definition of glass. Okay, so it is amorphous. Have you ever seen crystals of glasses? No, it's always very transparent. Unless and until something is very amorphous, cannot be very transparent. Glass has a typical very unique property of being amorphous and transparent. Okay, it possesses no definite formula or crystalline structure because we can add something for colors, and we'll get to know one by one as the video proceeds. It's an inorganic product of fusion which has cooled to a rigid condition without crystallizing. So if you prepare so many materials, chemicals, and if you start cooling them, most of them have the capacity to crystallize in a definite form. But glass, being amorphous, has no crystallization, and that is why it is transparent. Glass does not have a specific melting point, so it softens over a temperature range. Now let's see history and important inventions about glass. So glass making started about 3500 years ago. At some point long ago, humans realized that when lightning struck sand, the crystals are formed, which are useful. Now if you heat this sand, glass can be formed, is what they realized, and started experimenting on various types of sands. Firstly, Romans realized that glass objects can be made by blowing hot molten glass through a hollow tube. Now in current glass industrial production, main ingredient in glass is highest pure quality of silica sand. I have shown you the picture of that. They use recycled glass as much as they can instead of cullet sand. Okay, and then they add soda ash and limestone. I have given you the chemical formula for soda ash and limestone. Now you have to find out again the common name for soda ash, or the chemical name for the same is sodium bicarbonate. That is also I have given you. Now you have to find out a common name, daily use name for sodium bicarbonate or soda ash. I guess this is a very simple question for all of you. And here I have shown you the combination of the raw materials that we generally use for preparation of glass. Now, raw materials that we use in manufacturing glass are sodium as sodium carbonate. Okay. Then we use potassium as potassium carbonate. When we use potassium carbonate, the glass which we made is called as hard glass. When we use sodium carbonate, that type of glass is called as a soft glass. We use calcium as limestone or chalk and lime. We use lead as litharge or red lead, that is flint glass. Silica is known as quartz. White sand and ignited flint are the forms of silica that we use. So 72% of silica is used here in the manufacturing of glass. We also use sometimes zinc as zinc oxide. Borates are used as boric acid or borax. Cullets or pieces of broken glass are also used to increase the fusibility of the glass. Now, here I have again given you lots of different components of glasses that are used. Now let's see actual industrial production photographs and steps in glass manufacturing. Now here, as we have seen, different raw materials like calcium carbonate, waste glass, sand, sodium carbonate, everything is mixed here in the furnace. They are fed to the furnace. The furnace is heated up to 2500 degrees Fahrenheit. I mean 1400 degrees Celsius, just to melt all the raw materials and mix it properly. Then once they are molted, the gob is dropped into the mold, right? Now here at the end of the bottom of the mold, compressed air is forced in the glass just to give the shape of the mold. Now then this is the last is the finished product. Now this finished product are then on a belt, they are gradually cooled. Now to strengthen the glass, they go for reheating and gradual cooling. This process is called as annealing, which is very important in glass production. Now let's see the simple steps of manufacturing, which are very simple to remember. So first we take the raw material, we mix it, we add the cullet into that, and then the first very important step is melting, right? Then third is forming and shaping, and then annealing. These two steps, forming and shaping and then annealing, are very important. And then it goes for the finishing step. So cutting, inspection, packing and delivery. All the four steps can be included in one name as the finishing of the product. Then let's see some important properties of glass. Glass is amorphous. Glass is brittle, can be broken easily. Glass is transparent or translucent, and it is a very good electrical insulator. It is unaffected by air, water, acid or major chemical reagents except hydrogen fluoride. So HF, hydrogen fluoride, is a very acidic material. The size of this molecule is very small, so it can penetrate through your skin. It dissolves the glass immediately. Very dangerous chemical, HF. Glass has no definite crystal structure, means glass has high compressive strength. It can be compressed very well and can absorb and transmit and reflect light, right? So let's see some melting processes of glasses. Raw materials in proper proportions are mixed with batch, then it is fused in furnace at high temperature, and the important reactions which actually forms here are calcium carbonate and silica forms calcium silicate, and carbon dioxide gas is then released here. So after removal of carbon dioxide, we can decolorize the glass by using material like manganese oxide are then added to it to remove the traces of ferrous compounds. Ferrous gives you reddish color to the mold, right? The heating is continued till clear molten mass which is free from bubbles is obtained, and then it is cooled about 800 degrees Celsius and then fed for the mold. Then forming and shaping and annealing are again very important steps. Here the viscous mass obtained from the melting is poured into a mold, as we have seen in the last diagram, to get different types of particles of desired shape by either blowing or pressing between the rollers if we want a sheet of glass. Now annealing. Glass articles are then allowed to cool gradually at room temperature by passing through different chambers with descending temperatures. This reduces the internal strain in the glass. Now finishing. Finishing is the last step in glass manufacturing. It involves following steps: cleaning, then grinding, polishing, cutting, and finally sand blasting. So you have to blast the glass with the sand. Now let's see different varieties of glasses. These are different types of glasses. So I have listed 16 different varieties of glasses. Let's see them one by one. First we'll see Sodalime or soft glasses. About 90% of all glasses is Sodalime glass, made with silica, calcium carbonate and soda ash. The approximate composition, if you really want to jot down on paper, is sodium carbonate, calcium oxide and silica. Now whenever you see this tiny little dots in any chemical formula, then you must understand that all these components, so sodium carbonate is there as sodium carbonate, and this is mere a mixture of that and not a chemical bond is not there between sodium carbonate and calcium oxide, right? You got it? They are low cost, resistant to water but not to acids. Some of the acids really reacts, like HF reacts with glass. They can melt easily and hence can be worked out when they are hot. Now let's see the uses of Sodalime gas or soft glass. We make window glass, electrical bulbs, plate, then bottles, jars, cheaper tablewares, test tubes, reagent bottles out of soft glasses. Now second type is potash lime or hard glass. So when we use potash lime, potassium carbonate or calcium carbonate instead of sodium carbonate, that type of glass is called as hard glass. The approximate composition will be potassium carbonate, calcium oxide and silica. Now in earlier time we have seen sodium carbonate, calcium oxide and silica as the composition of the soft glass. They possess a high melting point. They fuse with difficulty and are very less acted upon acids, alkaline or strong acids and other solvents than ordinary glass. Now where do we use such hard glasses? We use such glasses, these are very costlier glasses than Sodalime glasses and are used in chemical apparatus, combustion tubes, glasswares which are used for heating operations. Lead glass or flint glass. Now it is made of lead oxide fluxed with silica and potassium carbonate instead of sodium oxide. So here what are we learning? If you little bit change the composition of the glass, the properties changes. So whatever application is needed, accordingly the manufacturing is done. Now it is approximate composition of flint glass is potassium carbonate, lead oxide and silica. To get dense optical glasses, about 80% lead oxide is used. Lead glasses has lower softening temperature than soda gas, higher refractive index, good electrical property. Now where do we use such flint glass? We use this high quality tablewares, optical lenses, neon sign tubes, cathode ray tubes, electrical insulators, crystal art objects, or cut glass, windows and shields of protection against X-rays and gamma rays in medical professions and in atomic energy fields. We need to use flint glasses. Then let's see borosilicates that we use mostly in chemical laboratories. It is a common hard glass that we use. It contains silica, boric acid, alumina, potassium oxide, sodium oxide and so on. Let's see uses. It is industrially used for pipeline of corrosive liquids. If there's some corrosive liquids we need to add in certain reactions in the industries, we use it. They flow through a glass pipeline where we deliberately use Pyrex or borosilicate glass tubes. Then we use such glasses in kitchenwares, in chemical plants, in television tubes and in electrical insulators. Now let's see alumino-silicate glasses. There we use silica, alumina, magnesium oxide, boron oxide, calcium oxide and sodium oxide. This type of glass possesses exceptionally high softening temperature. Let's see the uses. It is used in high pressure mercury discharge tubes, chemical combustion tubes and in certain domestic equipments like tabs and all. Now 96% silica glasses contains 96% of silica and boron oxide and traces of other materials. So this is the chemical structure of a glass. So this is kind of a network. So red dots are all oxygens and this blue dots are all silica. So these are polymers. So glass is a polymer. So they are translucent, they are transparent. They can their coefficient of thermal expansion is very low when we use 96% of silica. So they are resistant to thermal shock. So they can take any temperature fluctuations, have high chemical resistance, do not react to most of the chemicals. They are very resistant to corrosive. They do not corrode very immediately. So we use such kind of glasses at high temperature resistance is required. Wherever we require wherever we are using high temperatures, we can use such kind of glasses there. Then they are used in construction of chemical plants, laboratory crucibles, where we need to heat certain materials for high temperature. We can use such glasses, right? So here I have shown you a bowl of silica glass. We call it as crucible. We use such crucible, small cups, they look like small cups, and we put our material in that and we keep it in muffle furnaces for heating at 1100 degrees Celsius, 1200 degrees Celsius for 24 hours, 16 hours, 18 hours. We use such glasses. It contains pure silica heated to its melting point. It is translucent. Coefficient of thermal expansion is very low. So you don't need to bother about these words of thermal expansion, coefficient of thermal expansion. You will get to know or you will start using these these words as you proceed in your academic career. Okay. Now I have also told you the uses of it. Now safety glass. We use safety glass in many times, right? So it is made by fusing 2 or 3 flat sheets of glasses and between them alternate thin layer of vinyl plastic PVA or PVB film is used. And then it is heated where both the layers merge together. So these are layers of different clear glasses and then heat reflection films together, and then they are toughened. So where do we use such glasses? Where do we need that? It is used as windshield in automobiles and airplanes. On breaking it, pieces does not fly apart because of the presence of the plastic layer in between. Right? Optical or Crookes glass. What is it? It contains phosphorus carbonate, silicates and cerium oxide. So why do we use such ingredients? Because it has property to absorb ultraviolet light, which is very harmful. This glass is given through homogeneity by heating it for a prolonged period of time. So we use such glasses for making optical lenses. Okay. Now let's see about toughened glasses. Now it is made by dipping articles when they are still hot in oil bath, so that chilling takes place. They are cooled immediately. This results in outer layers of articles. They shrink immediately because of the immediate low temperature, and acquire a state of compression, while inner layers are in the state of tension. अशी परिस्थिती आपण निर्माण केल्यामुळे toughened होते हे glass, because the outer surface is quenched, is cooled quickly. So where do we use such toughened glasses? We use it for making window shields of fast moving vehicles in cars, windows of furnaces and automatic opening doors. Now how can we give colors to glasses? We use different chemical salts to give them particular color. So we use ferric salts to give yellow color. We use ferrous and chromium salt to give green color. Normally, by using manganese oxide, we can make a colorless glass. Then auric chloride is gold chloride for giving ruby color. Then red color is because of nickel and cuprous salts. This lemon color is because of cadmium sulfide, CDS. Fluorescent green color is due to uranium oxide. Brown color is due to iron, metallic iron. Blue color is due to copper sulfate. Isn't it interesting? Then wired glass. Have you ever seen a glass with a wired within it? Why do we use it and where do we use it? Wired glass does not fall apart into splinters. Okay, so when it breaks and is fire resistant, so when it is break, it will not broken apart. So they remain with each other because of the wires inside them. It is made by fusing wire in between the two glass layers, and we use such type of glass for making fire resistant doors, roofs, skylights and windows. Then let's see about fiber glass. Have you ever seen such fiber glasses anywhere? We use such fiber glasses for extensive manufacturing of fabric, reinforcing plastics in that, and we produce thermal insulation materials out of that, so that we can even use as a uniform for people who use people who work in furnaces or near furnaces. Then let's see how can we prepare photosensitive glass. Have you ever seen some people use their glasses, goggles, and when they go in sunlight, the glasses becomes colored? How do we do that? Let's get to know that. There are glasses which are colored picture may be developed by exposing the glass to black and white negative or in ultraviolet or in sunlight. The appropriate proportion of potash alumina glass, which is mixed with lithium sulfate, cerium and silver salts. All these materials are photosensitive materials. They give particular color when they are exposed to light. So we use such glasses. We all know that we need such glasses for very expensive goggles we use. Now what is glass wool? This is the picture of a glass wool. So glass wool contains tiny fibers formed by action of steam jets on dipping molten glass down from very fine hole. So you get such fine fibers of glass. So we use such fine fibers in heat insulation for filtration of corrosive chemicals. So for corrosive chemicals, we can't use normal wool or filter paper. For such filtration, we use glass wool. Or wherever we need sound insulation. People make music rooms, or there are studios where we do our recording. For that windows in between, we use glass wool for soundproofing. Now photochromic glass. Again the same funda. Three-dimensional silicate network contains large number of microscopic particles of silver halide. For this particular color, we need silver halide, silver iodide, silver chloride. But generally silver iodide and silver fluorides are used for photochromic glasses. Then let's see neutral glass. So neutral glasses are highly resistant to chemical attacks, and they are specialized Sodalime glasses where alkali has been replaced by alumina, boron oxide or zinc oxide. So we use such neutral glass for chemical reactions where we need syringes, injections, ampoules we call it as, and vials. Whenever you visit Science Park, ask me to show you vials, because we have vials in the Science Park, just to show you how we use it in laboratory. Then laminated glasses. So in between two glass sheets, we have a sandwich of polyvinyl chloride. The sheets of glass fiber or glass wool are soaked in a solution of thermosetting plastic with phenol formaldehyde resin, and then it is placed one above the other under heat or under pressure. It is strong as steel. Once you do this process, this glass becomes very strong, non-flammable and insulating. In bullet resistant glass vinyl resins are added in alternative layers of it. So we use it in shatters, shock and bulletproof glass. They are very expensive though. Now what are insulating glasses? So if I want a cooler inside my home, I will use such process. Two or more plates of glass are filled with dehydrated air. What is dehydrated air? Air where there is no humidity. The humidity content or water content in a air has to be zero. Such air is then filled in between two glasses, and then they are sealed tightly. In that case, whatever humid or whatever hot it is outside, inside you will feel cooler. Then how the fractures and failure of glass. Now the only failure of glass or disadvantage we would say is that it breaks. Glass does not have crystal lattice structure. It doesn't have a particular crystal structure, as I already earlier told you. Now because of this, fraction is caused by so small imperfections in the amorphous nature, and due to which glass breaks. Then that is it. Bye bye for now.